Okay, pi over 10. That is not one of the classic ones I had given you on Friday. That's not pi over 3, pi over 4, any of those. So pi over 10, I actually would have to go to my formula sheet and turn it into degrees before I start, because I have no idea what that is. So this is good review for Wednesday. Anybody remember what you got to multiply by? If I'm going radians to degrees. 180 over pi. Yep. So multiply by 180 over pi. We talked pi's will cancel each other out. 180 divided by 10. So that's 18 degrees. All right. So that's an 18-degree reference angle in quadrant 2. What's that look like? Need a little help from you guys? Where's the reference angle with the y or the x-axis? X-axis. So in quadrant 2, I need to make an 18-degree angle with the x-axis. So here is your reference angle, 18 degrees. It's asking for what was your original angle. Well, that was 18 degrees. If I went all the way to the line, it would be how many degrees? 100 and, well, all the way to this line here, 180. So to find the actual angle, what do I do with that 180 and 18? We still get confused a little bit by this. Should I add them or subtract them together? Subtract them. So that would be a 162-degree angle right there. So that's the first half. Find it in degrees. So that angle's 162 in degrees. Now it said also do it in radians. So what do I need to multiply 162 degrees by to go to radians now? What's the conversion on your formula sheet? Multiply it by pi over 180. Remember what we said? Don't put the pi in your calculator. Don't put it in your calculator. Leave it. And all I need you guys to do is reduce in your calculator 162 over 180. And I think it reduces to 9/10. So 9 pi over 10, or we discussed also 9/10 pi, whatever you prefer. Okay, so 162 as a degree, 9 pi, bless you, over 10 as a radian. All right. Anything else on the assignment you wanted to deal with? Okay, I don't know, you tell me if this is good news or bad news here. All we're doing today, review of 10th grade trigonometry, sine, cosine, tangent, 30, 60, 90, Pythagorean Theorem, those good old days in 10th grade, awkward sophomore years. All right. All right, let's get this set up here. Okay, ready to roll, guys? All right, let's shoot through this Pythagorean theorem. I'm not going to ask. A squared plus b squared equals c squared. The one thing you do just want to pay attention to, what type of triangle can it only be used in? It's not any triangle, only in right triangles, and that's the whole thing with today. Is everything we use today only right triangles. And you guys had A, B. Anybody want to show off and give me that fancy name for side C? Hypotenuse across from the right angle. Yep. Okay, let's use it. In right triangle ABC, go ahead. Right triangle ABC, but make sure you have right angle C. All right, make sure you got right angle C. And then A and B can go anywhere. And then what do you got? AC is a length of 2. BC is a length of 3. Find AB. And then I'm sure some of you, maybe last year, even in geometry, dreaded these directions. Simplest radical form, which means that nice little decimal in your calculator, no good for me right now. Useless. Okay, need somebody to set up Pythag for me. Here we go, let's roll. Yep, that's good. Good job. Yep. Want to set up Pythag for me? Go ahead, Cooper. Thank you. Go ahead, plug in the numbers now for me. Okay, well, calm it down, boss. Equals. I'm at 2 squared plus 3 squared. Equals And c squared. Thank you. Now we can go, yes, 4 plus 9. And maybe I shouldn't be assuming this, but what do we do on both sides? Let's take the square root of both sides. So c equals square root of 13. Don't go to your calculator. It's not doing you any good. Can you break down 13 at all? Is there any perfect square like 4, 9 that goes into 13 evenly? Anybody going into 13? Anybody? Got a little show off here. Yep. That's as far as you can go with that one. Don't need to break it down. How's my numbers doing over here? Worst time ever. All right, Laura. It's got a rectangular garden. Lucas, you got a garden or no? You garden at all? No. Anybody have a rectangular garden in their backyard? Vinny, no? Okay, just wondering. You probably have a gardener. I'm sorry. Yes. Mr. Hollywood over there. Yes. Okay. And it measures 12 feet by 15 feet. Perfect. So 12 by 15, doesn't matter where you put the 12 and the 15 here. And she's like, you know what? We're going to put a rock walkway on the diagonal. Bunch of rocks there. Okay. How long will that walkway be? This is all real life right here, huh? Next level. Vinny, you want to set up Pythag here for me? Looks like I'm going to have to get around to everybody today. Whoa, hold on. I got a question. Your entire class said you can only use Pythag on a right triangle. How do you know this is a right triangle? Okay, looks like it. It's a good point, isn't it? How do I know I'm working with the right triangle? What's the shape of the garden? What do you know about a rectangle? Finish your Pythagorean theorem. Yep. And you're welcome on the directions here. You don't have to simplify anything. I do need something to the nearest tenth, though. Back. What do you got, Brianne? Can I get a confirmation there? 19.2. She knows how to round. Good. Questions? All right, let's keep it rolling. Megan, you're up next here. I got find x. It is a right triangle. So go ahead, Pythagorean theorem. What's it going to look like with those sides? Okay, which we'll get to in a second. Yep, plus equals. Okay, perfect job setting up Pythagorean theorem. Guys, you're juniors and seniors now. Hopefully we're not just doing, x squared and 4 squared. All right, what do we have to do to this? I'm not a big fan of that term, but double distribute. Double distribute it. X squared minus 8x plus 16 when you double distribute. Hey, quick question there, kiddos. What do they both have on each side? X squareds, and they will cancel each other out. So I'm left with, looks like negative 8x plus 80 when I combine the 16 and the 64. equals nothing on the right side because the x squared canceled out. Ethan, what do you suggest I do now? Divide by 8? Okay, that's fine. Subtract. You could have added the 8x over 2, whatever floats your boat. And then x is going to equal what there, Ethan? Positive 10, yep. So just another way of doing Pythagorean theorem. Questions? We all good? Okay, so there's Pythag. Then I'm sure the next day in geometry you did this thing called 30, 60, 90, 45, 45, 90 triangles. Sound any bit familiar at all? Okay, why do I ask? I should just ask the wall and I get the same response. Okay, so let's find out. You are still dealing with a right triangle, but the degree measures in this first case are 45 and 45. Do you remember any special relationship between the sides? Anything at all? Well, let's start the sides across from the 45-degree angles. They'll both be yes. And I'm just going to say x and x. The sides across from the 45 are the same. Do you remember how you get to the hypotenuse? You multiply one of these sides by radical. No. No. Not at all. 2. Okay, you multiply one of the 45 sides by radical 2. And this is going to be even more painful. The 30, 60, 90 triangle. A right triangle with a 30 and a 60 now. What's the smallest side up there? The one across from the smallest side across from? Wow. Smallest side across from the smallest angle. Yes, so I'm just going to call that side x. Whew, boy. The hypotenuse is always 2 times that smallest side. All right, so whatever the smallest side is, the side across from 30, the hypotenuse is going to be 2 times that. So this one's always double this one. And the one across from 60, you're going to take that smallest side and multiply it by not radical 2, but radical 3. Nothing at all, guys, huh? Good times, sophomore year. Good times. I know that the only one I know that's a false statement for is Emma, but other than that, all right, because she had me. That's why, Annika, if you're wondering. Yeah. All right. That was quite a crew, Emma, right? That was. We had Nate sitting in front of you, I think, with his little caterpillar crustache. Yep. Yep. Does he still have that? Rocking? I have his little brother this year. He's got the same thing. I haven't said anything this year, but I will eventually. Okay, take a look at the first one here. If you're wondering why it's a crustache, because that thing is crusty. Right, that mustache. Okay. Too harsh. He's not even here, Brian, to back himself up. Too harsh. Right triangle ABC. You guys should know better at this point in the year. Right, Matt? Yep. Angle C is the right angle. Angle A. And we got angle A is 30. And I got, let's see, BC. What do we have there? Is that an 8? Yep. BC is 8. Find AB. Okay, Pythag out of the question because I don't know all 3 sides. Ready to go here, Reagan? You see how it's a 30, 60, 90 triangle. Okay, because that's 30, so that's got to be 60. What angle is that 8 across from? The 30, the smallest side, right? So it's across from the 30, and I'm looking for the side across from the 90. Do you remember the relationship between them? There's the side I have right now. There's the side I'm trying to find. So what do I have to do with this 8? Multiply it by 2. So x is going to be 8 times 2. That side is 16. No big deal back there, Cooper? Okay. Okay, that's pretty easy there, Vinny. It's not going to be that easy. Look at the next one. These ones get me going big time. A ladder leans against a wall. Where's the ladder? Also, the ladder leans against the wall. The ladder is another name for the what in the diagram? Thank you. If you think that's bad, wait till we get to the shadow problem later on, what I have issues with. The ladder's 12 feet, makes an angle of 45 with the wall. Got it. How far up the wall does the ladder reach? Got it. Ding, ding. Okay. Well, this is what type of triangle am I working with? Brooke, what type of triangle? 45, 45. Now I'm given the hypotenuse and have to go backwards. So this is going to be a little bit tougher. So here's what I'm going to suggest, and this is how I always teach it to the geometry kids. I make up a little chart, 45, 45, 90 chart. I put the rules inside first. So I know the rules are, if I go back to my triangle, x, x, and x radical 2. I got those right off the triangle I showed you guys first. Okay, Patrick, ready? Where's that side? And what angle is it across from? The 90. So that's exactly where I'm going to put it in my chart, is under the 90. Now, Isabella, ready? To go from the 45 to the 90, you have to multiply by what? Radical 2. So if I want to go backwards, what do you think I'll have to do? Not multiply it by radical 2, but divide it. Everyone in agreement? If I need to go backwards, I'm going to have to take that 12 and divide it by radical 2. All good there. Lucas, seem all right? Okay. Directions, though, said simplest radical form, so stop using your calculator. That decimal is useless. Make somebody proud last year, whoever you had. Can't have a radical in the denominator, but how can I get rid of it? Remember anything, Matt? Get rid of it. Multiply what by radical 2? Nice job. Top and bottom. You've learned well, young one. Nice job. You want to finish this then? What do you get on top? 12 radical 2. Can't do much there. And now on the bottom, when you multiply radical by itself, that's why, because I have no more radical. And finish. Reduce it to. There you go. Kids on point today. I like it. Did anybody used to cheat last year? And just, if you're given any number, just cut it in half and throw a radical 2 with it? Like if I gave you 100, what would be the side across from 45? If I gave you 100, cut it in half, 50 radical 2. Yep, not square root. I know you're thinking a little bit above everybody. Everybody good? You got a challenger here, Cooper. All right. Questions? All right, now let's put all of it into one triangle now. Go ahead. What I want you to do on this one, I'll give you guys 1 minute right now. Label everything I gave you, and then what I would like you to do is please label the missing angles as well. All right, so not only label the diagram with the info I gave you, but find all the missing angles too, please. So I'll give you a minute to do that. look who's back. It's over now. Okay, here we go. We're back in business here. Who's going? We're going right to 18. Who has 18? Matt? Did we have 18 the day we recounted? Guess not. 5? I know we had a 5 though. Hi Annika, how are you? I'm doing all right, thank you. What were your missing angles? What was this one right up here? Yep, nice job. How about the one next to 45? Okay, and then did you happen to find this missing one next to the 45? Okay, thank you. Nice job. All right, now I need a little help. Nope, come on, 11? You're going to do this to me again. No 11? 11? Okay, Anna, ready? Do you see a 45, 45, 90 triangle up here? Okay, it's triangle CBD. That's the one you and I are going to work in right now, that 45, 45, 90 one. Everyone else, here we go. We're going to work in it too. So I know I have a 45, 45, 90. So I'm going to get out that chart I just used in problem B. Fill it in with the rules right now, guys. Go ahead, fill it in with the rules. X, X, X radical 2. Only thing, Anna, I want you to focus on is triangle CBD. Do I know a side length in triangle CBD? 10. What angle is it across from? 45. So in underneath one of the 45s, I'm going to write 10 because I know that length. So that means what's across from the other 45? CD, which is going to be how long? Remember, these are both the same, right? X and X. So 10, and you told me, what's that side's name? CD. Got it. So there's CD, which is one of the sides we're asked to find. Okay, not off the hook yet, Anna. What about the side across from 90? Look what I do to X. I multiply it by radical 2. So what's the side across from 90? How long is it going to be? You got it. And for a bonus here, can you name that side? The side in triangle BCD. What's the side across from 90? BD. Excellent. Okay, everyone all good? So you've already found 2 out of the 4 we needed to find. We found DC and DB. Perfect. Thanks, Anna. 2. Hi, Megan. Okay. Do you see any other special triangle other than the 45, 45 Anna and I just worked with? Name the triangle that's a 30, 60, 90. ABC, right? Everyone see it? The full triangle is a 30, 60, 90. All right, so same thing. Ready? 30, 60, 90. If you got to look back at your triangle, go ahead. What do we put across from the 30, Megan? X. What's across from the 90? 2X, and across from the 60. You got it. And again, we are just looking at triangle ABC. Do you know a side in triangle ABC, Megan? BC, which is 10. Be careful now. Which angle is it across from? It's no longer across from the 45. It's across from the 30. Everyone see that now. It's across from the 30 now. So I'm going to put 10 here. Can we go across now, Megan, and fill out the rest of the chart? What's the length of the side across from 60? 10 radical 3. Now here's the part people struggled with third period. Name that side that's across from the 60. And remember, only triangle ABC. The side across from 60 would be what side in ABC? AC. Nice job. That's side AC. And if I started out with x equals 10, what's 2x? 20. Name that side in triangle ABC. AB. Great job. Go ahead, anything you want to ask, because that was about as tough as they come there. Notice we only use sides in triangle ABC. She didn't give me CD. She didn't give me BD, only sides in triangle ABC there. Anything else? Well, what if Pythag didn't work? And what if it wasn't one of these two special triangles? You resorted to one more thing, and that is Pocahontas' brother? No? Sokotoa? Legit, that was her. Anybody know Pocahontas? That was the movie, Disney movie. She had a brother, never even mentioned in any of the movies. You got the shaft, but it's Sokotoa. All right, yeah, Pocahontas' brother, Sokotoa. Great guy, just never got any of the publicity, and only in math classes, unfortunately. Okay, his sister took a lot of the limelight. Getting overshadowed by the sibling. Anybody relate in here? Overshadowed by the sibling. It happens. My poor sister, it happens. Okay, so what did that mean when you used it? Anybody want to fill me in here? Anybody know what any of the letters mean? Anything at all here? Any of the letters. There's a lot up there. What do you got? S is sign, and thank you so much, Megan, for not calling it sin. All right, that is an embarrassment. Sign, yes. S is for sign. Anybody remember what the O meant? Opposite, and the H? Hypotenuse. So that means sine is equal to opposite over hypotenuse. Anybody remember the C? Cosine. Yep, that's, what's the A? Adjacent over hypotenuse. And then finally the T? Tangent. Opposite over adjacent. So go ahead, set up triangle ABC for me right now in part A. You'll see why we need to use this. Angle C is the right angle. Doesn't matter where you put A and B. AC 20 and an angle of 37. Before we start, real quickly with your calculators, because we are in degrees here, just make sure you're in degree mode. I don't know if anybody tried playing around with it with radians last week, or if you gave it to a friend to play around with, you might want to look into that friend of yours. Make sure you're in degree mode. Find BC. All right, let's go. Whoa, number one. Where's the new number one here? Lucas, my man, here we go. You ready? Well, first of all, why no Pythag here? Why can't I use Pythag? It's a right triangle. Your ventriloquist over there? Good. Yep. And is it one of the special ones we just went over? No, it's not. Okay. So now here we go. We got to decide, Lucas, which one do I use? Sine, cosine, or tangent? You always go from the acute angle. We don't go from the 90. We always go from the acute angle. So in this case, 37. Is this X, this side X, opposite the hypotenuse in the diagram or adjacent to the 37? Opposite. Everyone's in agreement. So I know you may have not have done this, but I always like just to put a little O right there. That reminds me that's opposite. What about the 20? You'll have two choices now. Is it the hypotenuse of the diagram or adjacent? It's adjacent. So I have A and I have O. According to Sokotoa, Lucas, what do I use if I have the opposite and the adjacent side? Use your big boy words. TOA, yes. What's the T in TOA? Tangent. Thank you. So to write our equation, Lucas says use tangent. Of what? The angle we're using. What angle are we using, Lucas? Which is how many degrees? Yep, 37. So the tangent of 37. Keep going. Is equal to opposite, which we labeled as, over adjacent, which we labeled as 20. You're out of the woods now. Nice job. Other questions? This kid. All right, next one, not out of the woods. 12. 12. Okay, it's fine. Why did I pick the numbers? 2. Megan, you're good. I don't want to, no offense, I don't want to hear from you anymore. Plus, you'd probably try to correct me. Who's got 4? Ethan, there he is, in the back. How we doing? I can tell. How do you want to solve this beast? Thank you. Yes. Cross multiply. So x equals tangent of 37 times 20. Yep, and I'll go to my calculator for that. Just a quick little heads up. When you do tangent of 37, if you do that first, make sure you close it. And then multiply by, what was it, 20 or 30? 20. Yep, so it looks something like that. And what are we going, nearest 10th? Ethan, you want to round that to the nearest 10th for me? 15.1, yep. Okay. All good, everybody? Finding that side? Okay, now you can also use sine, cosine, tangent to find an angle. It's just different buttons on your calculator now. This one gets me going big time. You kids and what you're thinking sometimes. Okay, I'll worry about angle of elevation in a second. We got to get to this shadow thing right away. Okay, the student is 170 centimeters tall. Where am I putting that 170? Tall. 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 Is that what I'm seeing, Reagan, right here? See? Yes, 100s. Tall. Shadows, everybody. Look at my 2 options right now where I could put the shadow length. On the ground or beaming off your forehead. Because I will have people pick, yes, my shadow beams off my forehead when I go out on a sunny day. Please let me see that happen because you would be a freak of nature. All right, shadows, everybody, are on the ground. Yes, they beam right off your forehead. There's my shadow. Yep, instead of on the ground. Okay, now in all seriousness, let's get back to this angle of elevation. Anybody remember where the angle of elevation was located? It's the angle from the ground up. The angle from the ground up. So you're standing on the ground looking up. So this is my angle of elevation from the ground up. Okay, so here we go. Still need a little help here. Let's do this. 11, here we go. Oh, sorry, Anna. Thank you. Ready? Okay, here's my angle I'm going from, the acute angle. What's this 170? Is it hypotenuse, opposite, or adjacent? It is opposite, yep. And how about this 170? Is it the hypotenuse or adjacent? Okay, so for a second time in a row, what am I going to use with O and A? Okay, so you guys got tangent. Now remember I used 37 up here, but what am I using now? Well, no, those are the side lengths. I need an angle to put there. The tangent of, what'd you go from? X. So the tangent of X, some angle I'm trying to find. And you can't go wrong here, Anna. You can't go wrong. What's opposite? And what's adjacent? Okay. Anybody? I won't call on anybody here. We are not going to cross multiply like we did in the previous problem because we find an angle. Anybody know what special keystrokes I need to do here to get the angle measure? Cooper? You do the inverse tangent, second tan. That's only if you want to find an angle. Okay, so X is going to be equal to the inverse tangent of my ratio I just set up, 170 over 170. Okay, that's only for angles. See that, Emily? Only for angles, okay? If you need a side, you cross multiply. Okay, good talk. Go ahead, everybody. Second tangent. $1.70 over $1.70. What are you coming up with back there, Braden? Darn right. So that angle's 45 degrees. Don't look on the next page. Anybody remember elevation and what the other one was? Elevation, angle of, you're sad, depression. Yes, here we go. I didn't know what else to say, sorry. Okay, so here we go. Top of a lighthouse, 190 feet. Go ahead, and where should that 190 go? $190 feet high. Vinny, where should that go, please? Thank you. The height of it. Angle of depression is 34. Oh, you're right. Oh, well, that was elevation. Last problem. Here's my depression, the other angle. Nope. Nope. Then where could it be? Remember, hey, here's depression. You're on top of whatever, looking down with the horizontal line. So actually, it's going to be outside that triangle. All right, so what I need you to do right now at the top of the triangle, draw a horizontal line going across, and you have formed the angle of depression. You're on top, looking down from this horizontal line, so here's where depression is. And which side do we need to find if it's from the boat? Oh, we got a boat here. Hey, we forgot about the boat. Okay. That's as good as it's getting, trust me. Let's just say I had to take woodshop for my art credit in high school. All right. From the boat to the foot of the lighthouse. I need everyone's help here. I can't just randomly call on a number. I need everyone's help. I cannot use that 34 because it's not in the triangle. I can only, when I do SOHCAHTOA, I can only use degree measures that are in the triangle. And 90 is not going to cut it. I need another acute angle in there. So how can I use that 34 somehow to get another angle inside the triangle? A couple different methods. I need one inside. Cooper, suggestion. Oh, so you're telling me that because this is a vertical and a horizontal line, that's a right angle here. Everyone agree there? So I could do that and get that angle, subtract it from 90. Anybody else? Watch, ready? If that's 34, anybody know why that is also 34? Geometry term right now. Geometry term. Emma? No?
Something about parallel lines.
It is something about parallel lines. I need you to dig deep. Make me proud. There it is. Got it. Best teacher ever. Yes. 34. Yes. Alternate interior angles if you wanted to go that way. Thank you, Emma. You don't have to say a word the rest of the week. All right. You could say they're alternate interior, so they're both 34. Or I can go with Cooper's suggestion right now and subtract 90. What do we want to do? Just as a class decision here. I don't care. What do we want to do? Class decision. Okay, so we'll go with the 34 down here. That's fine. All right, so 34. What's the 190 then? Opposite Brooke, good. And the x would be adjacent for a third time in a row. We will be using tangent. It won't happen in part D, just to give you a little hint. Tangent of what angle? 34. Okay, now should we go 190 over x or x over 190? What's opposite? 190 over. I'm actually glad you guys decided to do this as a class. Go with the alternate interior. Cross multiply because we're finding a side. All right, Isabella, you ready? I need some help cross multiplying. Tangent of 34 times what? X, yep. Equals what on the other side? $1.90. What are you going to do to solve for X? Yes, thank you. Divide by the entire thing. Divide by the tangent of 34. Yep, and you guys can just plop that into a fraction template. I want to say 232, or did I totally botch that? 280? Okay. 282 to the nearest foot. All right, there you go, guys. Nice job. Assignment is down below and up on Aspen.